2, 1.
Hello guys and welcome back to our YouTube channel. Today we are diving into one of the most fundamental algorithms in the unsupervised learning, which is agglomerative clustering. So what is agglomerative clustering? It is basically it is a bottom-up hierarchical clustering method. That means that we start at the bottom, treating each data point has its own cluster. It has like I've shown a small dendrogram here, where the cluster B and C is merged together, and the whole cluster merges with the cluster A. So this is there are two types of agglomerative clustering: single linkage and complete linkage. So now we will be learning what is single linkage. So there is a single linkage rule. It calculates the distance between two clusters by finding the shortest distance between any single point in one cluster and any single point in the other. It always picks the closest pair. So there will be a numerical which will be explained in the next slide.
So now we'll be learning about single linkage clustering in a numerical. So here we have our data and our values. So first step is to create an adjacency matrix. So here how will we create this adjacency matrix? So basically for any 2 points, the distance between A, 1 minus 1 will be 0. Same thing for B, 1 minus 3 will be 2. So same way we will create for entire thing. And now we need to find the most minimum number. So here as we can see, the distance between CD, we are getting 1. So this will be our first point. Now in the second step, we need to find the single linkage minimum factor. So here since we got CD, now we need to merge CD into one. So now we'll find the distance between A with CD, B with CD and E with CD. So to find the distance of A with CD, we'll find the minimum of CA and AD. So as we can see here, the distance of CA is 4 and the distance of DA is 5. So the minimum of 4 and 5 is 4. Same thing we'll do for B with CD and E with CD. And now we'll fill it in this adjacency matrix. Now again from this we'll find the minimum number, that is 2. So now we're going to merge B with CD. So here it is. Now again we need to find the values. So now we'll find the distance of A with BCD, E with BCD. So here A with B, A with C and A with D. So as we can see in this, A with C is 4, A with B is 2 and A with D is 5. So here we get the minimum as 2. Same thing for this, E with B, E with C and E with D. We get the minimum of 6, 4 and 3, we get 3. Now again we'll repeat all the steps again. So now as we can see 2 is the smallest number. So now we'll merge A, B, C, D with E. So now we get this cluster. Now again here we get minimum as 3. So now we need to merge this one. So now we need to find the distance of A, B, C, D with E. So minimum of AE, BE, CE and DE. So that as per here we get 8, 6, 4 and 3. That is the minimum gets 3. Now we need to find the dendrogram. So to find the dendrogram, we just need to plot. So first we merged C with D as from here. So now we'll just merge C with D. Then we merge CD with B. So we'll show it like this. Then with A and finally with E. So this is how we solve a single linkage numerical.
Now we come to the advantages and disadvantages of single linkage clustering. The first advantage is it is very easy to implement. We just have to find the shortest distance between nodes and then find the shortest distance. And we have multiple algorithms to find this. So we can just implement it directly. Then we have to detect arbitrary shaped clusters, which is possible using single linkage clustering. But it might not be possible using algorithms like k-means or k-merge. Then it is used for clusters that are linked by chain or of nearby points. So when we know, let's say there are two clusters which are divided by one single cluster in the middle, that cluster might not be able to be founded by k-means or k-merge. But in single linkage clustering, it will be able to find out the specific shape of that cluster. Then it works even when clusters are not clearly separated. Like I mentioned before, when there is not exact linear boundary between them, single linkage clustering can easily cluster points based on its algorithm. Then simple distance based logic makes it easy to visualize and interpret. So as we know, some algorithms are very difficult to understand, but single linkage clustering is very simple. As we know, we just need to find the shortest distance between two nodes and just choose that. So it is as simple as it gets. And it is also very easy to visualize as how the points are clustered together using a dendrogram. Then the disadvantages are it is very sensitive to noise and outliers. For example, if there is a point which is way outside of the actual clusters, it will this algorithm will still consider and try to put that point into one single cluster, and it might ruin other points which are actually grouped together. It produces long stretch and chain like clusters. Like I said, if the points are long in a line, for example, this algorithm will try to cluster them together, but they might not actually be together. It might just be some random correlation between them. And it is slow and computationally heavy for large data sets. If there are like thousands of points, we need to find distance between each of them. And if there are multiple dimensions, then the distance computation also gets much more difficult. That's why it is not good for large data sets. Then it's not suitable when clusters are dense and compact, as it may break groupings. So, for example, there are multiple points which are very close together. Then the distance calculation will be differ by very few decimal points. So that's why when it is compact, it is not suitable, as it might not be able to find the clusters properly. Then it is connecting. Then it may incorrectly connect clusters that are actually far apart just because of one close point. So for example, if there are two clusters like this far apart and there's just one point in the middle, it might just join this together just because of this point. But in reality, these are two separate clusters. But just because this cluster is close by to this as well as this cluster, it makes the algorithm think that it's just one single cluster, which is wrong. So these are the advantages and disadvantages of this algorithm. Thank you for watching this video. I hope you liked it. If you have any doubts, please let us know in the comments.